very good morning. So my name is Gautam and I'm from Group Net Warrior 6 and this is my group mates Danish Rajvarman, Lachman, Tarishan and Kirti Nisha. So today we're going to present about our project. First, I start with project introduction. So the project title will be Secure E-commerce Infrastructure Design and Implementation for Nexus Retail Solution. And the goal of our project is to design and implement a robust secure network for commercial business using a three-tier security architecture. And the core strategy is utilization of a Cisco ASA firewall, segment tracking, trusted internal and semi-trusted DMZ, and untrusted external zone. Okay, now this is the IP address and subnet mask that we use for our project. First, we start from outside with internet. The IP address will be 205.1.50.16 and the subnet mask will be 255.255.255.252. The second one is inside LAN. The IP address will be 192.168.6.16 and the subnet mask will be 255.255.255.0. And the last one is DMS segment and the IP address will be 192.168.16.17 and the subnet mask will be 255.255.255.0. And now we move to the topology overview. The first one will be the inside segment, which is connect the ASA to switch 1 for employee workstation, PC1 and PC2. The second one will be the DMS segment, which is connect the ASA to switch 2 hosting the web, email and proxy servers. And the last will be the outside segment, which is connect the ASA to the ISP router to simulate the internet connectivity.
Okay, thank you, Gautam. So now I'll moving on to the core security implementation of our project. We focus on two main areas, which is network address translation and access control list. This configuration applied to the Cisco ASA firewall define our network security boundaries. So first we'll look at network address translation. First, let's look at NAT. We implemented two types of translation. Dynamic NAT. This was configured for our internal LAN. It's allow multiple employee PC to share the firewall's signal public IP address by accessing the internet, effectively hiding our private internal addressing scheme from the outside world. Next, static net. We created a one-to-one mapping for the DMF email server. This ensures that the external mail traffic can consistently reach the server at its specific host address. So next we will see to access control list. We enforce our security policy using ACL to manage traffic flow between trust level. So the first one is outside to DMF. We apply the out to DMF list to our outside interface. This follows a least privilege model. It specifically permits HTTP traffic on port 80 for our web server and SMTP traffic on port 25 for our email server, while blocking everything else by default. Next, we'll see inside to outside. For our internal user, we implemented a proxy only policy. As you can see in the inside to out configuration, we permit traffic only from our proxy server while exploiting direct internet access for the rest of the 192.168.6.0 subnet. This forces all web traffic through a secure gateway for better monitoring and protection. So thank you. That's all from me. Next, I'll pass to Lakshman to demonstrate the testing. Thank you.
Good day, everyone. My name is Lakshman. Thank you for the teammates for the previous explanation. So now I'm moving on to the technical demonstration. I will now showcase the secure network infrastructure we have implemented for Nexus Retail solution. As you can see, this is our topology. We have designed a zone-based security model centered around the Cisco ASA firewall. On the left, which is the yellow zone area, we have the trusted inside LAN for our employees. The security level is 100. In the middle, which is the orange area, we have the semi-trusted demilitarized zone area. The security level is 50. Here we hosting our web server, email server and proxy server. And on the right, which is the blue area, we have the untrusted outside network, which is security level 0, representing the ISP and the public internet. Now I will proceed connectivity test to prove that our security policies are enforcing the correct access rules. So the first test I'm going to perform is internal connectivity test. First we verify that our internal employees can access the company's public services. So to perform this test, I'm going to click employee PC1 in the trusted zone and going to desktop, click command prompt, and now I'm going to attempt to access the company website hosted in the DMZ, which is the web server. We should click web browser 92.168.116. So the web page loads successfully. This confirms that traffic is allowed to flow from the high security inside zone to the medium security demilitarized zone. The next test is external access and email test. So this is the critical test because we need to test the external public access. So we need to ensure customers reach our services but cannot touch our internal data first. I will test the email server. We configure a specific access control list and static NAT to allow SMTP traffic on port 25. So I'm going to click the external tester PC in the untrusted outside zone. Going to desktop, click email, and I am going to compose a email. So to user at nexus user1 at nexus.com, subject test email. I'm just putting like hello. So I'm going to click send. So you guys can see at the bottom of the page it says send success. So my test is success, and this proves our static NAT and ACL rules are correctly allowing external traffic to reach the email server. Alright, let's move on to the next test. Next one is the inbound security test, which is mean external to internal, untrusted zone to trusted zone. So let's verify our security boundaries. First I will demonstrate the inbound security. As an external attacker should never be able to initiate a connection to our internal LAN. I will attempt to ping the internal employee PC from this external device. So this is my external PC. Going to command prompt, and now I try to ping the employee PC in the trusted zone. So as you guys can see, the replies I get is destination host unreachable. So I can't make a connection to the inside zone. These confirm that the firewall is successfully blocking unauthorized traffic from the internet into our untrusted zone. Alright, move on to the next test, outbound security test, internal internet. To prevent data leakage and enforce company policy, employees are blocked from accessing the internet directly. They must use the proxy. I will attempt to ping the Google server directly from the employee workstation. So for example, let's click the example PC2, going to desktop, command prompt. I will now try to ping the Google server which is in the untrusted zone. So I'm waiting for the result. So as you guys can see, it shows request timeout. This proves that our access control is working correctly. It denies direct internet access for the internal LAN, which forces all web traffic to go through our secure DMZ proxy server. So next test, this is our last test, the bonus feature, advanced proxy access and switching. Although direct internet access ping is blocked, we still need our employees to access web resources securely. This is handled by our DMZ proxy server. Okay, to prove this, I'm going to the employee PC1 in the trusted zone. Choose web browser. Previously, I set ready the Google server domain name is www.google.com like that. So I'm going to enter the domain name here. Click go. So I'm waiting for the result. So the proxy server test is successful. I get the web page load successfully, and it's being served by our Nexus proxy server. This proves that while raw traffic is blocked, legitimate HTTP requests are correctly routed to the DMZ. So finally, for our switching verification, I'm going to choose the internal switch and going to hit this command, show MAC address table. So I get the result. The table shows dynamic learning of the connected devices, confirming that layer 2 forwarding is fully functional. So in conclusion, the simulation demonstrates that all connectivity requirements has been met. The firewall correctly isolates 3 zones, public services are accessible, and the internal network remains secure from external threat. That concludes the technical demonstration. Thank you, and thank you for Dr. Samshu to giving this opportunity. That's all from our group.